Have you ever looked up at the sun and thought, what a reliable, constant star? Well, it turns out our closest star is holding on to some pretty big secrets. We see it every day. It gives us warmth and light, but there's so much we just don't know about it. It's like living next to a neighbor for 4.6 billion years and only knowing their first name. Today, we're diving into the 10 biggest unsolved mysteries of the sun. Get ready, because things are about to get seriously astronomical. Let's start with a bang, literally. One of the most terrifying and fascinating things the sun does is produce enormous solar flares and coronal mass ejections, or CMEs. These are colossal explosions of energy and plasma that burst out from the sun's surface. And the mystery deepens. Not only do we not know when they'll happen, we also don't know their maximum possible energy. We have records of some powerful solar storms, like the Carrington event in 1859, which was strong enough to set telegraph offices on fire. That was the biggest one we've ever directly observed. But was that the sun's ultimate power punch? Or was it just a jab? This brings us to an even scarier concept, superflares. When we look out at other stars that are similar to our sun in size and age, astronomers have seen them unleash superflares that are hundreds, even thousands of times stronger than anything we've ever recorded from our own sun. This raises a chilling question. Is our sun capable of producing a superflare of that magnitude? The short answer is, we're not sure. Scientists have found evidence in tree rings and ice cores of massive radiation spikes from thousands of years ago, suggesting our sun has had more powerful outbursts in the past than the Carrington event, but a flare 1,000 times stronger. That would be a civilization-altering event. It would be catastrophic for our modern technology-dependent world. The fact that we don't know the upper limit of the sun's power is one of the most pressing questions in astrophysics today. We're living next to a giant that might be capable of a roar we've never heard before. Let's switch gears from the sun's temper tantrums to its birthday. How old is the sun, really? We often hear the figure, about 4.6 billion years old. And that's a great ballpark estimate, based on dating the oldest meteorites in our solar system, which are thought to have formed at the same time. But ballpark is the key word. We don't know its exact age in years, let alone the exact day it switched on. We do know the specific local cosmic event that triggered the collapse of the gas cloud that became our solar system. How long did it take for the swirling disk of gas and dust to form the sun and planets? Did the young sun go through phases of wild, variable radiation, like a flickering candle before it finds a steady flame? These details of its birth story are lost to time, and piecing them together is a huge cosmic puzzle. Now, let's talk about the sun's influence on us here on Earth. We know the sun has short-term cycles, like the famous 11-year sunspot cycle, which affects space weather. But what about the long game? How does the sun affect long-term climate cycles on Earth? Over hundreds or even thousands of years. This is a hot topic of debate. We know the sun's output isn't perfectly constant. It flickers and varies over time. But by how much? Is there a hidden grand cycle, maybe a 1,000-year cycle, or longer, that we haven't observed long enough to detect? And how much do these solar fluctuations really contribute to global climate changes compared to other factors? Separating the sun's influence from other Earth-based processes is incredibly complex, but it's crucial for understanding the past and future of our planet's climate. To understand the sun's behavior, we need to look deep inside it, and that's where we find one of the biggest mysteries in all of plasma physics. The sun's internal dynamo. The dynamo is the process that generates the sun's massive magnetic field. We think it's created by the motion of the electrically charged hot gas, or plasma, inside the sun. But the details are a complete black box. The sun's interior is a chaotic place, full of complex rotation and turbulent, swirling eddies of plasma. And then there's the truly baffling phenomenon of differential rotation. The sun's equator rotates faster than its poles. The equator completes a rotation in about 25 days, while the poles take more than 30 days. Why? How does this bizarre rotational pattern work, and how does it drive the 11-year cycle of sunspots and flares? Cracking the solar dynamo is a holy grail for solar physicists. Finally, let's look far, far into the future, to the end of the sun's life. We have a general picture of what will happen. In about 5 billion years, the sun will run out of hydrogen fuel in its core and will start to swell, becoming a red giant. We know this, but again, the devil is in the details, and those details are a mystery. Exactly how much will it expand? Will it swell up enough to completely swallow Mercury, Venus, and even Earth? Or will it just expand enough to scorch our planet's surface to a crisp? Current models give conflicting answers. After the red giant phase, the sun will shed its outer layers, creating a beautiful, glowing structure called a planetary nebula. But how long will this phase last? And afterward, when the sun's core collapses into a superdense white dwarf, how long will it take to cool down and become a stable dying ember? The final act of our star's life is a story whose ending hasn't been fully written yet. From its explosive temper to its mysterious birth, its deep inner workings, and its dramatic final days. Our sun is far from the simple, predictable ball of light we might think it is. It's a dynamic, complex, and sometimes violent star that still holds many of its secrets close. And the quest to understand it is more than just academic curiosity. It's about understanding our place in the cosmos and the forces that make life on Earth possible. Thanks for joining me on this journey into the heart of the sun's greatest mysteries. If you found this as fascinating as I do, make sure to hit that like button and subscribe for more deep dives into the wonders of our universe. Let me know in the comments which solar mystery you think is the most mind-blowing. See you next time.